Okay, guys, today we're going to continue with area formulas. We're moving into areas of trapezoids, rhombuses, and kites. First things first, we're going to look at is a trapezoid. And I don't need you to necessarily write down what I'm about to write down in red, but I want you to imagine that I take this trapezoid that I have drawn here, and I copy it, and I paste it, and I flip it, and I turn it around to where B1 is underneath and B2 is on top. And if you can imagine me doing that, what I would essentially create is one big, when you combine those two trapezoids together, one big parallelogram. And since the area of a parallelogram is just base times height, our base here is B1 plus B2, and that's our height. And that would be the formula if it was a parallelogram. But remember, a trapezoid isn't that whole thing, it's only half. So from the idea of a parallelogram, which goes all the way back to finding the area of a rectangle, the area of a trapezoid is simply 1/2 base 1 plus base 2 times height. And the reason that we have b sub 1 and b sub 2 is because in a trapezoid, these bases just aren't the same. Okay, so B1 and B2 are not the same length. If they were the same length, we'd either have a rectangle or a parallelogram. So almost by definition, those are going to be different lengths. So if you think about the formula of a triangle, 1/2 base times height, this is kind of a very similar formula if you're trying to memorize formulas. It's just that you have to add those two bases together. Now, if you're just finding the area of a... now, this works for both isosceles trapezoids and any other type of trapezoid. But if you're working on this and you have to work backwards, so let's say they give you the area and you're trying to look for one of the missing bases, that could be a little bit trickier. That's actually going to be a lesson that we save for Monday. So I'm not going to do any of those examples today. I'm going to save that for a separate lesson and kind of walk through that process with you for everything from both sections 10.1 and 10.2. So it'll kind of be like special situations with these basic formulas on Monday. All right, so the area of a rhombus and a kite. Well, we know a rhombus is a type of parallelogram. So one way of finding the area of a rhombus is if you have its height. Remember, height is straight up and down. It's an altitude. But if you have the base and you have the height, you could just use the area of a parallelogram and solve it that way, base times height. But in some situations, you're not given the base or the height. In some situations, you are given what, remember, we call the diagonals. So what's highlighted there in blue, that is a diagonal. Remember, a diagonal connects two non-consecutive vertices, and we have another diagonal here. So one highlighted in blue, one highlighted in red. Similarly, a kite has two diagonals. This one highlighted in blue, and that longer one there is highlighted in red. And so what's interesting about a rhombus and a kite is both of those have the same area formula, and the area formula for those is 1/2 the first diagonal times the second diagonal. And where that comes from, I'll just kind of do a real quick, that's a bad version of a kite. I'll just do a real quick sketch. Where that comes from, guys, is if you were to look at a kite, okay, and let's pretend for a second that we built a box or a rectangle around that kite. When we split all that up, the filled-in part of the kite is half that total area. And since this is D1 and this is D2, well, half of D1 times D2 would be the area. So that's where the formula comes from. You don't really need to know why it is generated or where it comes from, but we could also think of it almost as 1/2 the base times the height again, even if the kite is kind of on a diagonal or on a slant where it's not oriented straight up and down horizontally or vertically. All right, so let's just now take this knowledge and apply it to a few examples. Obviously, we're estimating here Nevada is not exactly a trapezoid. We've got some missing area there. But let's go ahead and do this according to our formula. According to our formula, the area of a trapezoid is 1/2 base 1 times base 2. Now think of the bases as the parallel sides. I realize some of you guys think base means it's on the bottom. It's on the bottom. It doesn't necessarily mean it's on the bottom. Remember the base, we talked about this before. The bases are the parallel sides. So that'd be 1/2 of 205 plus 511 times the height, which I know it's on the side here, but the height is 309. When we put that in our calculator, we end up getting 1/2 times 716 times 309, and we get a total of 110,622 square miles. So that's roughly the area of the state of Nevada. Okay. We go over here for the next example. I kind of used up some of my space, that's okay. What is the area of a trapezoid with a height of 7 and bases 12 and 15? So for this one, we're not given a picture. That's okay. If you're ever not given a picture, draw one. Has a base of 12, has a base of 15, has a height of 7. We don't even really need to draw the picture if we know the formula. 1/2 of 12 plus 15 times 7. I put that in my calculator, and I get 1/2 times 27 times 7, and what I end up getting is 94.3 centimeters squared. So that's what I get for that example. Keep in mind, guys, sometimes just like we had to do with the our triangles, we might have to figure out the height a different way. Sometimes we'll use trig, sometimes we'll use our shortcuts. Let's see here. So if I draw in the height there, now let's think about this for a second. If the whole length is 7, and that's 5, and that's 5, then what would be remaining here? Well, that would be 2. And if this is a 30, 60, 90 triangle, that would be the height 2 radical 3, if you remember that shortcut. If you don't remember that shortcut, it's okay. If you don't remember that shortcut, just simply use trig, okay? So if you have trouble remembering the 30, 60, 90 shortcut, just say, well, relative to that angle, this is 2, that's h, so that would be opposite and adjacent, so that would be the tangent. So the tangent of 60 equals the height over 2 times the tangent of 60 equals h. And if you put that in your calculator, what you'll find is you get the same thing as if you just did 2 radical 3. Either way, the formula is 1/2 base 1, which is 5, plus base 2, which is 7, times the height, which is either 2 tangent of 60 or 2 radical 3. It doesn't really matter which one you use. 1/2 times 12 times 2 radical 3 is going to be 12 radical 3, or 20.78 square meters. On the back, we look at another one here. I just used the same bases, but I changed angle. Let's say it's 45 degrees. Okay, well, if that was a 45 degree angle means that those are congruent. So again, if this is 5, this part would be 5, leaving this part to be 2. If those are congruent, then we would have a height of 2. So the area equals 1/2 of the first base, 5, plus the second base, 7, times the height, which is 2. So it's going to be 1/2 times 12 times 2, and this would be a total area of 12 square meters. Okay, we move on to a kite. There's a few things you might have to do with the kite. Let's say, for instance, I gave you the same example, but I didn't give you that piece right there. Okay, so let's say I didn't give you that piece. Well, you know in a kite that the diagonal KM bisects LN. So if you know that this half is 3, you would know that the other half is 3. So just keep that in mind in case you're not, given all of the information in a straightforward manner. Diagonal 1 So the area of a kite is 1/2 d1 times d2. Diagonal 1 is a total length of 6. Diagonal 2 is a total length of 7. And so we do 6 times 7 is 42, and half of that would be 21 square meters. Now, some people say, well, Mr. Ashby, how do you know that one's D1 and that one's D2? It doesn't really matter which one you call D1 and which one you call D2, because you can multiply in any order, and you'll get the same length. A few other things to note. We're not going to do a totally new example with this, but let's pretend for a moment that they didn't give us that equaled 2 for this length here. Maybe they didn't give us that, and so let's say they gave us that the outside was 6 and that this was 3. Well, how could we find that? Well, we could use the Pythagorean theorem, right? Because these are all right angles. 3 squared plus that missing value squared equals 6 squared. And so we could sometimes be not given every piece of information we need in a straightforward manner, and so we have to use Pythagorean theorem or trig or some other stuff to figure out the values that we need for our formula. All right, last but not least, a rhombus has sides 10 centimeters long. If the longer diagonal is 16 centimeters, what's the area of the rhombus? So I have a rhombus. Remember, in a rhombus, all sides are the same length. In this case, all sides are 10 centimeters. It says the longer diagonal is 16. So far, so good. I'm feeling pretty good. I got my formula. 1/2 d1 times d2. They gave me d1 was 16. So now I just have to figure out what my other diagonal is. And this, guys, is where I was just talking about a second ago. This is where I've got to use the Pythagorean theorem. I know that all of these intersect at a 90-degree angle. I have to use Pythagorean theorem. Well, if the whole thing is 16, then this piece is 8, and that piece is x. So I would have to say 8 squared plus x squared equals the hypotenuse, which is 10 squared. 64 plus x squared equals 100. X squared equals 36. X equals 6. X equals 6. Don't put 6 in for D2, because think about this. D2 is that entire length, so D2 is actually 12. So what I have to do is I have to put this 12 in as D2, and when I work all that out, I end up getting 96 centimeters squared. Hope that helps, guys. Do the homework that's listed on the task sheet and turn that into Schoology. Monday we will get together again and we'll do just some kind of special cases with these area problems. Hope that helped, and have a great day.